Hello my dear students. So I am going to continue the lesson Properties of Matter. You all can remember in the first chapter we discussed what matter is and the discontinuous nature of matter or particulate nature of matter. So here discontinuous nature of lipids. So what is discontinuous nature? You all can remember matter is made up of particles with spaces among those particles. So if we take matter, they exist in different states: solid state, liquid state and gaseous state. So under that, we have discussed some examples related to the discontinuous nature of solid matter. So in this chapter, we are going to start the discontinuous nature of liquid matter. So if you take a small volume of water and divide it into two portions. So let's say we have a small beaker with about, we'll say, 50 milliliters of water. Then what we can do is, we can divide this into two portions. So we will have two small beakers with 25 milliliters of water each. From that, you can take one beaker, again divide it into half. From that, you divide that volume of water into half a portion. Like that, you can keep on dividing it into smaller quantities of water until you are able to make it into the smallest volume. Maybe very tiny drops. You can take a vessel, a flat vessel, and on that you can place very tiny drops of water. How is that possible? Now, if water was just one continuous matter, then you will not be able to divide it. But you all know from experience, we can easily divide water or any liquid into smaller volumes. That is because this particular volume of the liquid is made up of particles. So if we take this, we'll say there are particles like that. Now out of these particles, when you divide it into two equal volumes, half the number of particles will go into one, the other half will go into the second beaker. So from there again, we divide it. Part of the liquid particles will go into one container, the rest will into the other container. And finally, when you make it into very, very tiny drops, there will be a few water particles. So this division is possible because liquids are made up of particles. And water is a liquid that is also made up of particles with spaces among them. So if we take a small volume of water and divide it into two portions, divide one of them again into two portions, that's what I showed you all here. Likewise, divide one half again and again until you get the smallest possible volume. So smallest possible volume, I told you all, drops of water. So even this drop of water can be further divided into water particles. And within the water particles, there will be space. So that means water is made up of particles. It has the discontinuous nature or the particulate nature. Now we will try to understand this concept by doing an activity. So activity, look into the discontinuous nature of liquid matter. So here again, we need certain materials to understand the discontinuous nature of liquid matter. So to do this activity, we need a watch glass. Then we need a beaker containing water. For that matter, we will be doing two activities. So for that, we will need two beakers containing water. Then we need condis. You all know what condis is. It is also known as potassium permanganate. Crystals. So we will be using potassium permanganate crystals. You all know they look like black color crystals, but you might have seen before also when you dissolve them, you get a nice purple color solution. So Condis or potassium permanganate crystals. Then we need ink. You can use ink or you can even use food coloring. Any liquid substance that has a color. So you can put a few drops of that liquid into water. So these are the materials. We need a watch glass to take the potassium permanganate crystals into it. We need beaker containing water. So water is one liquid, and also we will be using ink. So this is what we'll be doing. We will take some Condis crystals and we put it into water, that is water contained in a beaker. So we put a few crystals into it, we let it to stand for some time, then you observe what happens. After that, you will have to just mix the solution, that is the water containing potassium permanganate. You mix it well and then you observe what happens. The same way, we take another beaker containing water. We will be putting a few drops of the colored ink and you will observe what happens there. So that is the simple activity. I will discuss the method again and then we will do the activity. So the method. Fill a beaker in half with water and put a crystal of potassium permanganate into it. So you will have to take a beaker and in that you will take half amount of water and into that you put a small crystal of potassium manganate. I'll just write it as crystal here. So that has to go into water. You don't mix it or you don't shake it, you just put it in and you have to observe what is happening. Record the observations after about 5 minutes. So even for those 5 minutes, you can have a look at what is happening to the water inside the beaker. So then after 5 minutes, you can see what happens. Then shake the water in the beaker gently. So as I said, you can shake the water or you can use a glass rod to stir the water. Then you can observe what happens there. Again, state the observations. So that is one. Then the second part of the activity, add a drop of colored ink into a beaker containing water. Same thing, a similar activity here also. You take another beaker containing water and to that you put a drop of ink. So that also goes into water. So we make sure we use colored ink. It can be blue, green, red, any colored ink. And then we need to record the observation. So these are very simple activities. We use the water as the liquid and here ink is also a liquid. Here of course we have the potassium permanganate crystal. So there it is going to be a solid. If you like, you can also try with potassium permanganate solution. That will be a colored solution. That will be again similar to ink. So now that you have understood the steps of the activity, students, we will go to the lab and do the activity. Okay, students. So now we are going to do this activity in order to understand the discontinuous nature of liquids, or what we call as the particulate nature of liquids. You all know what that is. Liquids are made up of particles. That means they are not continuous. That's why we call it as discontinuous nature. So to start the activity, I have potassium permanganate or what we call as Condis and water here. So what we need to do is we need to take a small amount of potassium permanganate. You all can see the color looks almost like black in color, but you all know when it dissolves it gives a purple color. So I will transfer this small amount of potassium permanganate into water. You all can observe how the color spreads through water. Can you all see the change there? Then what we need to do is we need to leave this aside for about 5 minutes and then we will observe what happens. So initially you can see here students, there's clear water at the surface or above and the potassium permanganate is spread throughout the bottom of the beaker. While you observe, you can see the potassium permanganate, the purple color rising up. How is that possible? Water is made up of particles. Potassium permanganate is made up of particles. So when the particles mix together, the color spreads throughout water. So that is how we can confirm that water is made up of particles, or water has the discontinuous nature of matter. That means liquids have the discontinuous nature of matter. So we have to allow it to stand for about 5 minutes. So students, while we wait for 5 minutes for the color to spread throughout, I will do the second part of the activity where we use a colored ink. But here, instead of colored ink, I have food coloring. Either way, both are liquid substances and they have a color. So here, I have the green color food coloring. What do? We take a drop of the food coloring and put it into water. So again, you can see what happens there as well. So both are liquids. In the first activity, condensed or potassium permanganate is a solid, whereas water is the liquid. But here both substances are liquid substances. So here when I put, you all can see how the color spreads. A drop of food coloring. You all can nicely observe the spreading of color. I'll put another drop, then you can observe it. So here again, water is made up of particles. The coloring is made up of particles. You all can observe how the color spreads throughout the water. That is because the particles of both substances, both liquids, mix together. That confirms matter or liquid matter is made up of particles. Now can you all see? So now you all can see students, the green color has settled down at the bottom of the beaker. What will happen when we mix the mixture? So here if I try to mix this, you can see how the color spreads. Can you all observe the spreading of the color? Little by little the color spreading throughout. So if I keep on mixing it, now you can see the solution is completely green in color. So again from this also we can observe that liquids are discontinuous in nature. The green color particles of the food coloring spread between the water particles of water. So because they are particles only, the mixing is possible. So initially the color went down, now the color is spread throughout the solution. So the same way students, you all can see here the potassium permanganate slightly rising up. But for that to happen completely and mix well with water, it takes a longer time. Now we have waited for almost 5 minutes. So what I am going to do now is, I am going to just shake this beaker. You all can see while I shake it, there is more potassium permanganate spreading throughout the liquid. But as you all can observe clearly, you all can see the movement of potassium permanganate. Similar to the coloring here also, now the color has spread completely throughout the liquid. But what happens if we mix the solution? Again you can see the intensity of color increasing, that is the solution becoming more darker and darker. Why? More potassium permanganate is mixing with water. So now we have the potassium permanganate solution or potassium permanganate completely dissolved in water. And you can see the purple color spread throughout the solution clearly. So this also again confirms the discontinuous nature of matter. How do we explain this? Water is made up of particles. Potassium permanganate being a solid, that is also made up of particles. The potassium permanganate particles and water particles mix with each other. So because they are particles only, the mixing is possible. So from that, we can confirm that is made up of particles, or the matter that is solid potassium permanganate and liquid water show discontinuous nature of matter. Okay, students. So, you all observed what happened when we put a crystal of potassium permanganate into water. What did you all see? You all were able to see that the color spread throughout the water. So, the purple color of potassium permanganate spreads throughout water. After 5 minutes, what did I do? I moved the beaker so that we can shake the water inside. So, there you were able to see the more spreading of the purple color, and finally the full water or the solution inside the beaker became purple in color. So, that was one observation. So, here if you look at this diagram, this is similar to what you all saw. Initially when we put a crystal, you all were able to see the crystal spread along the water little by little. That is the color of the crystal. Like this, you saw it moving upwards. Initially the bottom part was darker in color. Then the lighter purple color spread throughout the water. Then after 5 minutes, you were able to see that the full solution became purple in color. How was that possible? Water is made up of particles. Potassium permanganate crystal, although solid, that is also made up of particles. When you put the crystal into water, the particles of potassium permanganate move through the spaces present between the particles of water. So that is why the color spreads throughout, and also the potassium permanganate crystal dissolves completely in water. So from that we can conclude that water is discontinuous in nature. So here first I will write down the observation. So the crystal started to dissolve and the purple color of potassium permanganate spreads through water. Then what did we do? We shake the beaker. When the beaker was shaken, the color spreads throughout and finally the solution becomes purple. That was the observation of the first activity. Then what did we do? We did the second activity. We put a drop of colored ink. I told you all you can also use food coloring as well. So when you put that, what happens? The color again spreads through water. The next activity, the color of ink spreads through water. Then the solution became colored. So those were the observations. So as I told you all students, we can come to a conclusion from this activity. Conclusion. What can we conclude? Because the colored ink or the potassium permanganate particles were able to move through the spaces present between the water particles of water, the color was able to spread throughout the solution. So from that, we can conclude and say water is discontinuous in nature, or water has particulate nature. That means liquids are discontinuous in nature, or discontinuous nature of liquids can be confirmed. So that is the conclusion that we can get from this activity. So we can say water is discontinuous in nature. That is, liquids are discontinuous in nature. We can explain this I explained this to you all during the activity, and just before writing the conclusion also I explained. What is the explanation? Water is made up of particles of water particles with spaces in between the particles. Similarly, ink and potassium permanganate crystals are made of particles. The color spreads through water because the colored particles So here students, I am writing it as colored particles because we use two substances, the ink as well as potassium permanganate crystals. So the colored particles were able to move through the spaces between water particles. So that is how we were able to confirm. So you can remember students, now we have the beaker that has water in it. So there are water particles like that and there are spaces. So what happens? The potassium permanganate particles or the ink particles, they are able to spread through the spaces. So the two types of particles, water particles and the colored ink or potassium permanganate particles can mix together because they have the discontinuous nature or the particulate nature. So that is what you need to understand from this activity. So I am sure you all can get that concept. Water is made up of particles, potassium permanganate is made up of particles and they have space between the particles. So that's why one type of particle can move within the spaces of the other particles. So then the color spreads. So that is the activity to demonstrate that liquids are discontinuous in nature. So I'll go back and go through the slide again. So this is what we were able to observe. The crystal started to dissolve and the purple color of potassium permanganate spreads through water. Then after that, when the beaker was shaken, the color spreads throughout and finally the solution becomes purple. So at that time, the particles are completely mixed together. The same thing with the ink. The color of ink spreads through water, then the solution became color. So from that, we were able to conclude that water is discontinuous in nature. From that, we can say that is liquids are discontinuous in nature. So I have given you all the explanation as well. Water is made up of water particles with spaces in between the particles. Similarly, ink and potassium permanganate crystals are made of particles. The color spreads through water because the colored particles were able to move through the spaces between water particles. So that proves that they are all particulate in nature. I am sure you all can understand that. So this is what I have shown you all here as well. So with that students, we will move on to the next slide. So there is an assignment. Plan and implement some simple activities to demonstrate that liquid matter is particulate in nature. How can you demonstrate that? You all do this in your day-to-day life. Say you drink something in the morning. Say you drink milk. To milk, you might like to add sugar. So how does this sugar dissolve in milk or even in water? Sugar is particulate in nature. It is discontinuous. So the sugar particles are able to move through the spaces present between the milk particles. So therefore, sugar can dissolve in water. So that explains the particulate nature or discontinuous nature of milk. The same way, you have say water, you have a fruit juice, let's say orange juice or lime juice. You can squeeze lime and you can get the juice. So both of them are liquids. When you mix them together, you get the lime juice, the less sour one. So to that also you can add sugar. So there, water is discontinuous in nature, lime juice is discontinuous in nature. So you are able to mix them. The particles of the two liquids mix properly because there is spaces between the particles. So from that we can confirm that the liquids are discontinuous in nature. The same way, we have already discussed dissolving potassium permanganate. Similar to that, you have these watercolors at home. It can be the solid slab colors or the tube colors or tub, whatever it is, you can take the watercolor, you can dissolve it in water. Like with potassium permanganate, you can even put a drop of watercolor into it and you can observe what happens. You can use food coloring. That is also colored. You can put a few drops of the food coloring into a vessel containing water and you can observe what happens there. In all these instances, because water is discontinuous in nature only, you are able to see the color spreading throughout water. The same way, the taste of lime juice, it spreads throughout water. That is also possible because water and lime juice both are liquids and both are discontinuous in nature. So here they have told you all to plan and implement some simple activities to demonstrate that liquid matter is particulate in nature. So when they say plan, you can nicely show them, okay, take two equal glasses or one large glass and a small glass. So the large glass with water, water filled up to half the level with water, and then in the small glass you can have lime juice. If it's all clean vessels and clean glasses, you can taste it also. So you can pour the lime juice into water and you can see it mixing. So before that, what you can do is you can taste water, you can taste lime juice. So you know the taste. Once you mix lime juice and mix it well, you will get the different taste of the lime juice in water. So from that you can confirm and say, okay, lime juice has completely mixed with water. So that is how we plan and implement some of these activities. So I will just give you all the ideas. You all can think of many innovative ways to put them as activities. So here I'll write down a few of those. So first I told you all you can mix sugar with milk or dissolve in water. Even that is okay. Dissolve in water. So there are also you can get the taste. You know, once you dissolve it completely throughout the solution, throughout the liquid, the taste will be the same. That means the sugar particles have completely spread throughout water. That is one. Then you can mix lime juice and water. For this matter again, it can be lime juice or any other juice you all like. So in these two instances, you can observe or you can taste it because you are doing it at home. You can use clean glasses, clean water, everything if it's possible. Then clean, then you can drink and taste it and see. Otherwise, you should not taste anything. If you are doing an activity in the lab, you all know that, students. Chemicals cannot be touched with your hands or it cannot be tasted. But if it is in your household, you all can taste these two first two examples. The solutions can be tasted. Then we can also say put a few drops of food coloring into a glass of water. The same way you can dissolve a small amount of watercolor in water. So these are all different examples where you can demonstrate the discontinuous nature of liquids. In the first one, milk is a liquid or the water is a liquid. Here both lime juice and water, they are both liquids. Then here again, water is the liquid. And the fourth example where you use watercolors, that is also a liquid. So in addition to that, students, when we use sugar, we also consider the discontinuous nature of solids because sugar is a solid. So you all know the concept very well now. That is the discontinuous nature of liquids. So with that, students, I will move on to the next slide. So then we will discuss this activity to understand the discontinuous nature of gaseous matter. So activity, verify that gases are discontinuous. So for that, these are the materials that we need. We need 2 gas jars. You all would have seen this in the lab, or maybe you would have used it in the lab. Gas jars. And we need 2 of those. So here you can see this is a very thick glass jar. We can take a colored gas into one jar, and on that we can place the other jar, invert it and keep it on the other jar so that you can observe the spreading of the gas. So if you want to observe the spreading of gases, we need to have a colored gas. So for that we use this one. This is reddish brown in color, and that is the nitrogen dioxide gas. So we will be using nitrogen dioxide gas. Students, you all don't need to worry about how we prepare the nitrogen dioxide gas. I will be using it. It is reddish brown in color. That's the important thing. So for the first part of the activity, we need 2 gas jars and the nitrogen dioxide gas. We will be producing the nitrogen dioxide gas in the lab, and we will take that into one gas jar. Over that, we place the second gas jar in the inverted position. So both the mouths of both the gas jars will be in contact. The colored gas, you can see here, the nitrogen dioxide gas, it's a brown color or nice reddish brown color gas. You can see what happens to that color. Then as the second activity, we will be using joysticks. Or you can say incense sticks. Joysticks or incense sticks. You all know why we use these joysticks. When you light the joysticks, you will get the fragrance spreading throughout the room or the area where these are kept. And you all know they are available in different fragrances as well. So we will use that as the second step in the activity or second part of the activity where we light the joystick and we observe what happens. Then for the third part of the activity, we will be using a perfume. So you all know when we say perfume, students, the perfume has a nice fragrance. Instead of a perfume, you can also use an air freshener. So perfume, or you can use air freshener. So what we will do is we will take the perfume or air freshener and spray it and observe what happens. So here when we say observe, it's not only watching, you have to observe the fragrance or the smell spreading throughout. All that will give you an idea about the discontinuous nature of gases. So before we go to the lab, I will go through the method again. So the method here, this is the first step. Fill a gas jar with brown colored nitrogen dioxide gas and close it with another gas jar. So this is what we need to do, students. We have a gas jar here. And on top of that, we place the second gas jar. And inside, we will have the nitrogen dioxide gas. So initially, there will be nitrogen dioxide inside the first gas jar. Then you can observe what happens after 2 minutes. So record your observation after 2 minutes. When you say after 2 minutes, it's not after 2 minutes. You just fill it into this, place the second gas jar, and you have to observe for 2 minutes and see what happens there. Then as the second step, we light a joss stick. Then the third one, place some perfume in a watch glass and leave for some time. And you need to record your observations. You all know when you light the joss stick, not only the fragrance, you can also see the fumes coming off. A greyish color fume. You have to observe that. And also what happens when you have a perfume, a small amount of perfume in a watch glass. Or else we can spray the air freshener and observe what happens. So those are very simple activities, 3 different activities to understand the discontinuous nature of gases. Now we will go to the lab and do the activity. Okay, students. So now we are going to observe the particulate nature or discontinuous nature of gases. To do this activity, I have a few things here. I have 2 gas jars. I will be preparing nitrogen dioxide, and you all should remember that it has a reddish brown color. So we will observe how the gas spreads through air. That is to confirm that air is made up of particles and nitrogen dioxide is made up of particles. So we can confirm that gases are made up of particles, or gases have the discontinuous nature of matter. Then to do the same activity, I have the joss stick here. If we light the joss stick, and you can observe how the smoke and the fragrance spreads throughout air. In addition to that, you all can use perfume, or else I have air freshener here. Again, that also has a fragrance, so we can try to understand how this fragrance spreads through air. So students, now I have prepared nitrogen dioxide gas here. You can see the brownish color gas there. What I am going to do is I am covering it with a cardboard so that the gas does not escape the gas jar. Now I am going to place the second jar over this. At the same time, I am going to remove the cardboard as well. So you can see how the gas spreads from one jar into another jar. Now observe carefully what happens. Can you all see? There is darker color here, and when we come to towards the top of the first gas jar, you can see the lighter color, and here it is colorless. But with time, you will observe the change. You all can see little by little the color rising up from the bottom gas jar to the top one. So this takes a little time. We might have to wait for about 2 minutes. Okay students, now we waited almost for 2 minutes now. You all can see the rising of color. Now here it's very darker in color. Towards this part you can see the light brown color. But in the second jar also you can observe the brown color mixing with white color. So in the second glass jar you can see students the brown color spreading throughout the gas jar. So how is this possible? Now inside the gas jar there is air. Air is made up of particles, and nitrogen dioxide is a gas that is also made up of particles. When the nitrogen dioxide gas particles spread through the spaces of air particles, we are able to observe the color spreading into the second jar. So that is to confirm that nitrogen dioxide as well as air. Both are gases. So gases are made up of particles. That is, gases show particulate nature or discontinuous nature of matter. You all can still observe the change in color, how the brown color spreads throughout the second gas jar. Can you all see here, students, the color rising up? So that is the spreading of particles, nitrogen dioxide particles within air particles. If I move the gas jar a little bit, so you can see the rising of color a little bit more clearly. Okay, students, while we wait for this observation to be completed, we'll give some time for the gas to spread throughout the second jar. I will move on to the second part of the activity where I will light the joystick. So you all know what happens here. Right. So if we light the joystick, students, so here you can see, students, the fumes coming from the joystick, the burning joystick. So that is spreading throughout air. You all can observe that. You would have observed this at home also. And normally you all know the joystick has a fragrance that also spreads across the room. Say if you're a little far away from me, then you will get the fragrance. How is that possible? The particles of this fume along with the fragrance spread through the particles of air. Because there is space between the particles of air, that is, air is discontinuous in nature, this observation is possible. So here also, even the fumes, they are in the gaseous state, they also can spread because they are made up of particles. So from this observation also, we can confirm that both the fume that is coming from the joystick as well as air is of discontinuous nature. Right. So here again, students, you all can observe the color had spread through into the second glass jar than before. So that also is an observation that you all have to notice. Then we have this air freshener here. As I told you all, students, instead of perfume, I have the air freshener that also has a fragrance. So when we spray the perfume like that, you all can see how the it gets sprayed. So that is also possible because that is made up of particles that can spread through air, and after some time you all can get the fragrance from a far away distance, slightly away from the bottle, you still get the fragrance, and the fragrance again spreads out throughout the room after some time. So that is again possible because air is made up of particles and the perfume spray that is also made out of particles. So the particles of one substance spreads through the spaces of the second substance. That is again made up of particles. So from all these observations, and again if we look at the nitrogen dioxide here, now you can see when compared to the initial stage, there is more reddish brown color spread throughout the two gas jars. So from the three observations, students, the nitrogen dioxide gas, that is the brown color of the gas spreading from one gas jar into the other. The joystick, you all saw the fumes of the joystick spreading throughout air, and the air freshener being sprayed into air, as well as, although you all are not able to understand the fragrance spreading through air, you all have experience because at home or in school you would have come across this where you get the fragrance. When you have the joystick burning at one point, you can get the fragrance throughout the room. The same goes for the air freshener. So all these are possible because all these substances which are in the gaseous state, they are made up of particles, as well as air is made up of particles. So the particles of one substance that is in the gaseous state mix with the particles of the other substance, spreading through the spaces between the particles. and that is what we call as the particulate nature or discontinuous nature of gases. Okay, students. So, you all were able to observe what happened during the activity. So, first we took the nitrogen dioxide gas into one gas jar. You all can see this is the gas jar, and on top we place the second gas jar. So, like shown in the diagram, little by little you were able to see the color moving, the brown color of nitrogen dioxide spreading throughout the air, because inside this gas jar initially there is air, but you were able to see the spreading of the color, and finally after some time there is like a uniform color. Still you can see towards the bottom the color is a little more intense or darker, but towards the top you get a nice yellowish color or light brownish color, but still the color has spread throughout the two gas jars. How is that possible? Initially there is air inside the gas jar. Air is a gaseous substance, gaseous matter that is made up of particles. Nitrogen dioxide gas is also a gaseous substance, again made up of particles. So, the brown colored nitrogen dioxide gas particles spread through the spaces between the air particles. So, because of that, the color can spread throughout the gas jars. From that, we can conclude and say both air and nitrogen dioxide, they are gases, and these gases are discontinuous in nature. That was the first part of the activity. So, I will write the observation first. The brown color of nitrogen dioxide gas spreads into the second gas jar. That was the observation. So, after I write down all the observations, I will give you the discussion as in the previous activity, and then we will write the conclusion. So, what was the second one? We lit the joss sticks. Joss sticks. So, when we use the joss sticks, what happened? You were able to see the grey color fume spreading throughout the air. Of course, you all did not get the fragrance. I told you all I can smell the fragrance as well. How is that possible? Say you have the joss stick here and your friend is standing in front. The grey color fume as well as the particles of the joss sticks, they spread through the air particles. So, between air particles around us there is air. Air is made up of particles. Between those particles there is space, and between the spaces the joss stick particles spread and reach you. That is why you get the fragrance. So, here you can see spreading of the grey colored fumes in air was observed. And also the smell of the joss stick can be felt, or you can say you can smell the fragrance of the joss stick. That is also possible. Then we did the third activity, that is with the air freshener. That also you all know, students. Again, you all can't smell it because you all were not there in the lab with me, but you all know. At home or in workplaces, even in school, sometimes they spray the air freshener. You all use perfumes. Then there are different types of fragrant substances. When you have it in one place or when you spray it in one place, you can get the smell or the fragrance from a distance. Not a very long distance, but within the room, you can get the smell from any part of the room. How is that possible? Again, the same explanation. There is air around us. Air is made up of particles. It's discontinuous. There is space between the air particles and the air freshener particles or whatever particles, perfume particles, they are also particles. They move through the spaces present between the particles of air. So from that again, we can confirm that air is made up of particles or air is discontinuous in nature. For that matter, gases are discontinuous in nature. So here again, fragrance of the air freshener or perfume can be felt. Or you can say, you can smell the fragrance of the air freshener. That is the third observation. So from all these observations, we can write the discussion. What can we write as the discussion? There is air inside the gas jar. Nitrogen dioxide and air are gases or gaseous state matter. So the particles of nitrogen dioxide spreads through the space present, we can say spaces present between the particles of air. So that is the explanation for the first one. The same way we can explain the second part as well. So we can say perfume or joss sticks are made of particles responsible for their fragrance. When these particles move between the spaces present in air. The fragrance spreads through air. So that is the explanation. So from all these students, we can come to a conclusion. What is the conclusion? Air again is a gaseous state of matter. Nitrogen dioxide is a gaseous state of matter. So they are all discontinuous in nature. Therefore, we can say gases are discontinuous in nature. So here again we can say air and nitrogen dioxide are gaseous state of matter. They are discontinuous in nature. Therefore, gases are discontinuous in nature. So that is the conclusion that you can get. So here students, these activities are mainly to demonstrate that gases are discontinuous in nature. So from the beginning, we discussed what discontinuous nature is, and thereafter we looked at different examples, different instances that help us to understand that solids are discontinuous in nature, liquids are discontinuous in nature, and now gases are discontinuous in nature. So I will go back and again go through the observation and the discussion as well. So here you can see the observation, the brown color of nitrogen dioxide gas spreads into the second gas jar. That was the first activity. Then we saw in the second activity with the joss sticks, spreading of the grey colored fumes in air was observed, and also the smell of the joss stick can be felt, or you can smell the fragrance of the joss stick. Then when we used air freshener again, we can feel the smell of the air freshener. So fragrance of the air freshener or perfume can be felt. So you can smell it from a little away from the perfume or the air freshener. So from that, we came to this discussion where we said there is air inside the gas jar, nitrogen dioxide and air a gaseous state of matter. They are gaseous state matter, and the particles of nitrogen dioxide spreads through the spaces present between the particles of air. So both of them are particulate in nature. And also the perfume or joss sticks are made of particles responsible for their fragrance. So when you spray this perfume or when you burn the joss stick, the fragrance particles spread through air. So when these particles move between the spaces present in air, the fragrance spreads out through air. So here this has it be. This is in air, the fragrance spreads through air. So from that students, we can conclude and say as conclusion, air and nitrogen dioxide are gaseous state of matter. They are discontinuous in nature. So therefore, we can say therefore gases are discontinuous in nature. So that is the conclusion that we can get from this activity. So I am sure now students you all can understand the discontinuous nature of matter well. So with that I will move on to the next slide. Assignment. So here again plan and implement with your teacher simple activities to support the fact that gaseous matter has a particulate nature. So basically we have carried out the simple activities already in the lab. So if you are in the lab, you can prepare nitrogen dioxide gas, that is a brownish color gas, or you can even produce bromine gas, that is also a brownish color gas, or else chlorine gas that has a light yellowish green color. You have learnt about chlorine before, but sometimes the chlorine is not that visible, but bromine gas is more visible. So we can either use nitrogen dioxide or we can use bromine gas. So similar to the activity that we discussed before, you all can plan and show that the colored gases spread throughout air. The same way, you all have seen in some countries they have this festival of colors, where they use this colored powder. They either put it on, they just apply it on the faces of their friends or relatives. At the same time, they just spread it, they just spill it in air so that you can see the color filling the air. So that is also an observation where you can demonstrate the discontinuous nature of air. So you can use colored powder, you can just spread it, sprinkle it through air, and you can see the color spreading. From that you can explain the discontinuous nature of air. Or you can, if you can get the fumes, the black color fumes, when you burn firewood, you would have seen the smoke coming out or fumes coming. Those are all made up of particles, and you can see the smoke spreading through air. So with that also you can demonstrate the discontinuous nature of gases. So those are a few examples. As I told you all students, I will give you all an idea as to what you can use, but you all are very innovative, so you can come up with a method to use this concept. So here we can use again nitrogen dioxide, or you can use bromine gas. Both are brown in color. So you can show the spreading of colored gases through air. That is one. Then you can sprinkle colored powder in air. That is again to demonstrate the particle nature or discontinuous nature of air. Then the third one I told you all, can show that smoke from burning substances like firewood, spreads through air. You have even seen sometimes, if you all have visited the cement factory. So there is lot of cement particles, cement dust in the atmosphere. So there also sometimes you would have seen the particles with the wind, with the blowing of the air, you can see the particles moving. It's like a cloudy color. The same way, if you are in a place where there is lot of sand, the reddish brown sand, when there is blowing also, sometimes even the sand blows with the wind. So there also you can see the blurriness or cloudy nature. If you can use that concept, say you can have a container or a paper with very dry sand and you can blow the fan towards it and you can show it spreading through air. Like that you can come up with new ideas. So that is also another concept that can be used to demonstrate the discontinuous nature of gaseous matter. So here I have given you all a few ideas. We have already used nitrogen dioxide gas. You can also use bromine gas. Those are both brown in color. So you can show the spreading of these colored gases in air or through air. Then the same way you can spread colored powder in air and you can show the color spreading throughout. The same way you can show that the smoke from burning substances like firewood, that also spreads through air. That also can be used to demonstrate the discontinuous nature of gases. So with that students, I am sure you all were able to understand the discontinuous nature of solids, liquids and gases as well. So students, from all these activities and observations, now you all can clearly understand that all matter, irrespective of their state, whether they are solids, liquids or gases, it doesn't matter. They are all discontinuous in nature, or you can say they are particulate in nature. And you all have understood what that is. All types of matter, solids, liquids and gases, they are made up of particles. They are constituent particles, and between those constituent particles, there is space. So that is what we mean by discontinuous nature of matter. So in the next chapter, we will discuss the 3 states of matter in detail and their properties, as well as how we can use those properties in our day-to-day life.